Lesson 4.11, Parallel and Perpendicular Lines. One of the very most important things to remember when we're talking about parallel lines is that for parallel lines, the slopes are always the same. And it's really it's very important to understand that the slopes are the same, but they don't have the same y-intercepts, right? Because if they had the same slope and the same y-intercept, they'd be the same line, all right? Now, if they have the same slope, parallel lines will never intersect, all right? So if they were on a graph, they'd look something like this, right? They would never intersect. Perpendicular lines, I think it's just going to be best for me to show you an example of what that's going to look like there, okay? So what we need to make sure we understand as far as this worksheet goes in the symbols, parallel lines, the symbol looks like train tracks. For perpendicular lines, it looks like an upside down T. And then for just plain old intersecting, right? They're not parallel or perpendicular, but they do intersect, so we just have that X. All right, let's look at example number 1. First, if we need to decide whether or not they're parallel or perpendicular, we just really need to look at the slope. So what's the slope for this purple one? Well, that's just going to be 3. Okay, for the second one, what's the slope here? Well, again, it's just 3. So since my slopes are the same, those are parallel lines. Okay, and if you ever want to double check, you can go to your calculator. You can go to y equals, and you can actually plot both of those, right? So 3x plus 4 is the first one. 3x minus 7 is the second one. And we can really get a good visual here, right? What do we get when we graph? Yeah, we have two parallel lines there, right? They're never going to cross. Let's go ahead and let's look at problem number 2. All right, the top equation in purple, what is my slope here? Hopefully you can quickly tell me it's -4. For the next one, we have a different equation here. I'm going to do that in yellow. What's my equation for this one? Sorry, not my equation, my slope. Just 1/4. Now I'm going to go ahead and tell you that these are perpendicular lines. All right? The way that we know that they're perpendicular is we know that they have two things going on. The first thing to know is that they have opposite signs. When you have lines that are perpendicular, one will be positive and one will be negative. So we're going to say opposite signs. The second thing we need to notice is that they are flipped, right? I had 4 and then I had 1/4. They're flipped. Now the proper math word for this, we say reciprocal. All right? Some teachers tell you to always take the slope that's opposite reciprocal. Sometimes you might also hear me say flip it and switch it, right? Flip it over, switch the sign. So those lines are perpendicular. Now, in your calculator, it might be a little bit tricky. I want to show you guys something. When we put in these new equations, just to check, -4x plus 1, and then the second one is going to be 1/4 x plus 3. When I graph them, the way that my calculator defaults with its screen, the intersection doesn't really look perpendicular, and we need to know that perpendicular means they cross at a 90-degree angle. All right, I probably should have mentioned that sooner, right? 90-degree angle if they're perpendicular. Now, these don't really look like a 90-degree angle, but that's because my screen is stretched. So if you really want to see the screen looking the right way, go ahead and hit zoom. And if you want it to be perfect square, you need to actually tell your calculator to do that as a perfect square. So if we make the screen unstretched and make it a perfect square, and we graph, okay, that definitely looks better. That is in fact a perpendicular intersection right there with those lines. Okay, let's go ahead and let's look at number 3. In number 3, my original slope is, my top slope in purple there is 2. My second slope on the bottom there is 1/2. All right, so are these parallel? No, they're not the same. They need to be exactly the same for parallel. They're actually not perpendicular either, right? They don't have different signs. So they cannot be perpendicular. That means they must just be regular intersecting lines. Now, what does this look like in our calculator? Well, we have 2x minus 5 for our first equation. And my second equation, I have 1/2 plus 10. 1/2 x plus 10, right? So when I graph these, what do I see? Okay, my other line, I'm not even able to see it right now, so let me make sure I can see a little bit higher. We'll do 20. Look at that graph. Okay, something's wrong here. 1/2 x plus 10. Oh, I put 51 for the top one. Oops, you guys notice that? Sorry. Delete that 1 here. Let's take another look. We'll just go back to the regular zoom. There we go. All right, yeah, we can see that they intersect, but they definitely don't intersect at a 90-degree angle, so they're not perpendicular, but they're also not parallel, so they're just regular lines. Okay, finally, let's look at number 4. In number 4, we have y equals 4 and y equals 6. Now, hopefully you guys know that this graph would look something like that, right? And the other one would be the same thing, but it's just higher. So that means our slope is horizontal, which means a slope of 0 for both of these, right? Because I don't have x values in either of them. So that means my slopes are 0. Since the slopes are the same, they're parallel. All right, let's move on. Let's look at problem number 5. In problem number 5, it says find the slope of the line parallel to the given equation. So if my original slope is -2, then my parallel slope is -2 because parallel lines have the exact same slope. Don't overthink it. Problem 6. Problem 6 is not as nice because I don't know the slope right now, right? I can't see the slope right now. So what I need to do is I need to do a little bit of work here to get the slope, which happens when we get y by itself. So we're going to get 8x to the other side. So we've got -7y equals 14 minus 8x. And now I'm going to get rid of that -7. And I'm going to have y equals -2. And then we've got -8 over -7, so we're going to have a positive, and let's just leave that as a fraction here. So this is my equation for that. All right, well, we can see that my slope is 8 over 7. So my parallel slope, you guessed it, also 8 over 7, right? My slopes for parallel lines are the same. Problem 7 and problem 8, we're doing a very similar thing that we did in 5 and 6. However, this time we're looking for equations where we have a perpendicular lines. All right, so my original slope is 2 over 7. So my perpendicular slope, we have to do the opposite sign, which means since this is positive, my new slope will be a negative. And then we flip this. We take its reciprocal. So now instead of 2 over 7, I have 7 over 2. Remember that flip it and switch it phrase we talked about? That's what that looks like. All right, problem 8, same thing, but this we have a little bit of pre-work to do here. We have to take care of this, get y by itself so we can see our slope. All right, got -2y equals 8 minus x. Finally, divide by -2. And I've got y equals -4. Negative divided by a negative is going to be a positive. Let's throw a 1 up here so I can kind of see it. That looks better. That's a positive 1 over 2x. All right, so if this is what I'm starting with, right, that's a positive number, right? We have m is equal to 1/2. Then what's my perpendicular slope? Well, my perpendicular slope is going to be negative, right, because my initial 1 was positive. And then we're going to flip it over. So I got 2 over 1. Now, we really don't need to leave it like this. We don't need to put divided by 1. So really it's just -2. All right, that is my perpendicular slope for this equation. All right. Last but not least, how you will probably be tested over this, and something you're going to need to do in geometry is you're going to need to be able to find equations that are parallel, but that also go through a specific point. So let's look at this problem here. This problem says, write an equation parallel to the given equation. So parallel to y equals 3. All right, well, let's first take care of this, y equals 3. That line is going to be horizontal, and it's going to be right here. I strongly recommend graphing for these questions. I can't tell you how strongly I recommend graphing when you're doing this, all right? So I have a parallel line. Now, says write an equation that's parallel to this. Well, I could draw here or here or here or here. Like there's tons of different lines that are parallel. So we have to be more specific. So they say draw a line that's parallel, but that also goes through this point 4, 7. So 4, 7, I know these are a little blurry, is going to be right there. Well, now we are down to only one line. There's only one line that's parallel to this one that also goes through this point. And so I guess that's going to be right. It's a different color. Let's do right here. All right, so this is my line. Now we have to write an equation for this. So what's the equation of that red line? Well, it's horizontal, so we know it's y equals, and it crosses at 7, so that's your equation, just y equals 7. All right, last problem here, problem number 10. We are talking this time about a perpendicular equation, right? We need a perpendicular line to this line. And then it also needs to go through this point. You know what? I'm getting ahead of myself. Let's go ahead and let's graph this initial line that we were given. All right, so we're going to have a point at 5. All right, now my slope is -1/5, so I'm going to go down 1 and right 5. Right, down 1 and right 5. So here's my equation. Sorry, here's my line. Looks like this. All right. Now, I'm supposed to come up with a line that is perpendicular to this. All right, so I could draw a line like that, or like that, or like that, but it is more specific, right? It wants us to go through this point right here, -2, -3. So let's draw that on the graph. So -2, -3. So that point is right here. So I need a new line. My new line is going to go through this point. What do we know about our new line? My new equation, it's going to be y equals, shouldn't I already know the slope, right? What's the slope for my given equation, the one I already graphed? Isn't the slope just -1/5? So what would be the slope for my new line? Wouldn't we change the sign so it's positive, and wouldn't we flip it, so now it's 5/1? So my new slope is going to be 5x. Oh man, but I still don't know the value for b, right? I still don't know what I'm going to put right here, right? What's my b value? What we're going to do to find this is we are going to graph. I know I have to include this point because it was given to me. And I also know the slope is 5. Guys, I'm just going to use that, right? So from my point, I'm going to go up 5/1. I'm going to go up 5, 1, 2, 3, 4, 5, and I'm going to go over 1. Okay, there it is, right? This is the y-intercept. This is the point that I was missing. And now I can just kind of see it in the graph, and that's how I can find it, right? What's the y-intercept of my new line? Let's see, 1, 2, 3, 4, 5, 6, 7. That is going to be 7. So that's a positive 7. This is my equation, right? I knew the slope because it's the opposite reciprocal of the given, and I graphed it to find the y-intercepts, right? I used the initial point and the slope to find the y-intercepts. When you are finding parallel and perpendicular lines, I already said it, I'm going to say it again. Please, please, please get yourself some graph paper if you don't have it already and draw.